Hello, welcome back. Our next little video in this Financial Maths Grade 11 is going to be depreciation and inflation. I'm going to start off with depreciation though, and the definition of depreciation is that it's a reduction in the value of an asset over time. So it would be, most commonly would be your computer printer, your projector, your cars, your vehicles, your bakkies, anything that is considered an asset when you deal with accounting, because this essentially is like an accounting principle and things you need to know. So the interesting thing is depreciation is written off as a tax cost. It can be taken off when you do your returns. But the thing that we're interested in for our level of maths is that in depreciation, there's a difference between straight line depreciation and compound interest depreciation, which is also called reducing balance depreciation. And once again, it's the formula that are different. The formula again are given on your formula sheet. So in the straight line depreciation, it's A equals P 1 minus I to the n. The only difference is that you are subtracting instead of adding. And with the compound interest, once again, the same thing, A equals P 1 minus I to the power n. So that's essentially the only difference in the two. And if we visualize it again, because I think it's very important to visualize it, is your straight line depreciation is going to look something like this until it ends up at a value of 0 rand, 0 cost. There's nothing left. It's completely kaput. Whereas our reducing balance depreciation looks something like that. So if you compare the two depreciations, you might find initially that because of the exponential form of depreciation, this will depreciate a lot quicker, but at some point they will cross over each other, etc. And the interesting thing is that with compound depreciation, it never actually reaches 0. Look here, because it's of the shape of the graph, it never hits 0. In other words, it never becomes 0 here. And if you think of it in terms of solving for an unknown, when it becomes 0, you can see that can only become 0 if either your initial amount is 0, which it can never be, or this here is 0, and that can never be, because even if that's a fraction, it can become a small decimal, but it can never become 0, because n is always a positive value. Interesting, isn't it? So this is depreciation. We're now going to look at a few examples, and then we'll move on to inflation. Okay, so let's tackle some examples about depreciation. So in example 1, the value of a vehicle is 320,000. If it depreciates at 14% per annum, calculate the value of the vehicle in 5 years' time, if depreciation is calculated using the straight line method. So that is going to be simple interest. So we've got our formula. Don't forget it's a minus instead of a plus. And then we plug in our values. And I think it's pretty straightforward. Don't forget 14% is the same as 0.14. And we get 96,000 Rand. Now the second type is if we use the same values, but we use the reducing balance. So let's see what that looks like. So it's still 320,000, 14%, but for 5 years, and because it's compounded, it is to the power of 5, and that gives us 150,536 Rand and 65 cents. Now if we compare these two values, with straight line depreciation, the value of the vehicle after 5 years is 96,000, and the value of the vehicle using compound reducing balance method is 150,000. So in terms of our graphs, just to see what this looks like, straight line, remember, is going to do that, whereas our reducing balance is going to do this. So you probably find we're somewhere around there after 5 years, because the reducing balance is worth more than the straight line balance, which is there. Okay, let's move on to a second example. Oliver buys a printer for 6,400, sells it 3 years later for 3,000. Calculate the annual rate of depreciation if we first use the straight line method and then we use the reducing balance method. Okay, so in this particular, if he buys it for 6,400, that's going to be his initial amount and it becomes 3,000, so that will be the A. Just watch out for those two. Plug in your P, plug in your A, plug in the number of years, and then we work backwards. So remember, we divide by the 6,400, we subtract the 1, and then in the end you would divide by -3, and we would get an interest of 0.177083. And don't forget, because we want it in as a percentage, we times it by 100 to get 17.7%. Okay, happy. Just go through it again. I'm going fairly quickly because I'm assuming this is basic algebra solving for unknowns. Then the reducing balance method. Don't forget, we deal with the exponential because it's a compound interest formula. Fill in your A, fill in your P, fill in your N. And once again, we take that across first. That's always the first thing we do. So we divide by the 6,400, take the cube root of that, subtract 1, and then we would end up with a negative on both sides. So we would just divide both sides by a negative, and we would end up with a rate of 22.3%. Okay, I think as you have these worked examples in front of you, you can just press pause and go through them slowly. But I think it's pretty straightforward. Thank you. Okay, we've had a look at depreciation. Now we're going to have a look at inflation. And inflation, in a nutshell, is a general increase of prices over time, or the fall in the purchasing value of money. So if you talk about the economics of it, you're either going to talk about the increase of prices, or if the price stays the same, the value of the purchasing value of the money goes down. So either price increase, values go down. So essentially either way you're losing value. So inflation, two very important points to remember. The first thing to remember is we only ever deal with compound interest formula with inflation. We never look at straight line, only compound interest formula. So it's always going to be this formula here that we're working with, the exponential one. And secondly, inflation is always calculated annually. It's never compounded monthly, compounded quarterly, it's only compounded annually. So if they want the inflation in 5 years' time, N will be 5. It won't ever be messed with. It's only worked out annually. Obviously, there are many, many other ways of looking at it, but for our purposes at grade 11 level, these are two very important points. Compound interest only and calculated annually, where N is compounded annually. Sorry, the interest rate is per annum compounded annually. Okay, now let's do some examples. Okay, now we're on to some examples of inflation. But before we get started, let's remember two very important things. The first thing is that inflation is only calculated annually, in other words, once a year. It's never compounded quarterly or monthly, etc., just compounded annually. And the second thing is we always talk about compound interest with inflation. Okay, so our first example. In 1985, a 2-liter bottle of milk cost R1.72. Presently, in 2022, a 2-liter bottle of milk costs $24.99. What is the percentage? Okay, so if we look here, we dealt from 1985 all the way to 2022. So that essentially is going to be our N. 2-liter bottle of milk costs $1.72. So that's the original. And now it costs $24.99. So that's your final amount. So if we plug the values in, remember it's always our compound interest formula. You have A, we have P, we have N, and we're looking for R. N is just going to be the number of years from 1985 to 2022, which is 37 years. Remember, in solving for this unknown I, we always start with by dividing by the 1.72 And in the next step, we get rid of the power 37, and we get rid of it by taking the power to the 37th root. And then in the final step, we take the 1 across, and then we times by 100. And that is going to give us the final percentage of inflation, which is going to be 7.5%. Okay, hopefully you're fine with that. Let's move on to the second example. A data projector currently costs 13,000. That's now. So that's going to be our p-value. How much will the same projector cost in 3 years' time if inflation is calculated at 6.5% per annum? Remember, we always deal with the compound interest formula, so it's to the power n. Our present value of the projector is going to be 13,000. Your interest rate is always over 100, so it's 0.065, and to the power n, which is 3 years. And we end up with 15,703 Rand 34513 cents. Now remember, we want to round this off to 2 decimals. So just a quick recap. You look at then the third decimal, which is a 5, which is going to round that up to 0.35 cents. And with rands and cents in financial maths, it's always 2 decimal places. Okay, there you go. Can I have a look at the examples? Try them on your own and practice a few more. But easy peasy lemon squeezy.